Hey guys, that's the video dedicated to question 2, exercise 12.1, chapter 12, that's about linear programming and problem solving. Okay, so here is very similar question that you have in your books. So I decided to develop my own objective function and my own constraints, but the idea is pretty the same. Okay, so you need to minimize your objective function here subject to the following constraints. Okay, let's move to the next slide where I'm going to explain, but you guys try to pause the video, try to do by round, that will be good practice for you, and let's compare it with my explanations. Okay, so here is the xy set, and the first step here is to define the region. So relating to those inequalities x more equal than 0 and y more equal than 0, have a reference to question 1 where actually I explained that this is the first coordinate. So right now we are here, x and y should be both positive. And we are interested in the line L1 with the following equation x plus 3y. Instead of inequality, we consider equation of the line. So that's linear constraints. So the equation for that is going to be a straight line. And we set up xy set in order to drop the points on Cartesian plane, and we need to have 2 points for the line. Okay, so if x is 0, y equals 2, and vice versa. If y is 2, if x, let's say, if x is 6, y is going to be 0. Okay, we've got 2 points, 2 and 6, so it's right there, 2 and 0, and 6 for x. So 1, 2, 3, 4, 5, 6, it's right there. And hence, the first equation of the line, let's take a pink color, is going to be that one. So that's our line. That's L1. With the equation x plus 3y equals 6. Okay, so we move next, and we need to set up another line, which is L2. And let's say the equation for that is going to be 3x plus 2y equals 6 instead. Okay, so where is the line? The line also according to the set of points x and y set. So we're going to set up the values for that. And the first, we can say that if x is 2, y is 0. If vice versa, y is 3, we've got x is 0. So this line should go through 3. This is the y-intercept. It's right there. And also should go through 2. It's right there. So I'll use the blue color for that. So I'm going to use that. Let's take purple one and just connect those two. Okay, so where's our region? It's right there. I'm going to highlight the region. So let's choose that color. And that's going to be our region as the common region for intersections of all inequalities. One more time how I define that. So we have x plus 3y less or equal than 6. If you transfer x to the right side, you understand that y is going to be less than the equation of the line. So that means it's below the pink line. Also, you can do the same for line 2 with the equation 3x plus 2y equals 6. So if you transfer 3x there, you'll get 2y. So in inequality. So for example, I'll show it this way. So 3x plus 2y less or equal than 6. So for example, you can transfer in that way. And in this case, you understand that your y, even if you divide by 2, so your y is less or equal than the equation of the line, whereas the equation of the line actually represents this purple line. Okay, so that's why it's below again. And once we're restricted for x and y to be positive and equals to 0, so everywhere we have non-strict inequalities, that allows to include the boundary. Okay, so that's our region. Now what I'm going to do, I'm going to zoom in. So we've got that. And by the way, I also put z function as well. So I just write there our objective function z, which is negative 3x plus 5y. And right now what I'm going to do, I'm just going to zoom in. What we need to do, we need to minimize that. So minimize. Okay, so minimize. That what we need to do with our z objective function. So we have bounded region, so no problem. We just mark up vertices. I'll use green color for vertices. So let's draw it 1, 2, 3, and 4. So actually the region represents quadrilateral. And let's set up all the points in the table. So I'm going to use that one. So let it be the table. So, okay, that's for x column, y column, and z column for our objective function. So good. Let's set up x, y, and z as our objective function there. All right. So what I'm going to do, I'm going to first calculate all the vertices if I don't have it. For example, for that one, for this green point, I don't have the vertex. So, I don't have the coordinates itself. So what I'm going to do, I'm going to recalculate and clearly state what the coordinates. So what I'm going to do, this is the L1 intersect with line 2. So in this case, intersection will give us the following fact that we need to solve the system of equations. So x plus 3y equals to 6, and also 3x plus 2y equals to 6. So we need to solve this simultaneously. It means that what we can do, there is the way we can multiply by 3. So we can use substitution method when you actually express, let's say, x through y and plug into the next equation. But hopefully I can do by elimination. So I multiply the first equation by 3, and then I subtract the bottom part of, so the bottom equation from the first one. So I simply subtract, this is the first one, so I subtract from 1, 2, and as a result I'll get 3x will be cancelled, so here will be 9y minus 2y. It's going to be 7y will be equal to 18 minus 6 is going to be 12. So y coordinates for that point is going to be 12 over 7. Okay. So what about x coordinates? In order to find x, we simply need to say that it's 6 minus 3 times y value. So we plug y back into the equation. So we've got 6 minus 3 times 12 and over 7. So let's recalculate and see what we have. So actually you can use, guys, you can use fractions if you like. So maybe it's highly recommended. So 7 times 6, 42 minus 36. So we've got 42 minus 36 and over 7. That's our fraction. And lastly, we have 6 over 7. Okay. If you estimate, so if you want to check whether we're correct or not, so 6 over 7 is 0.857. So it's about 0.857, so over 86 to 2 decimal place. So for y, we've got 12 over 7. It's going to be 171. Okay. Yeah, it looks like so. If you estimate, it's going to be 1.71. Okay, so now we have 2 coordinates for the vertex, so we can mark actually. So if that vertex, what we can do, we can say that it's going to be vertex coordinates 6 over 7. And for y, we have 12 over 7. 12 over 7. So that's the coordinates. And now what we're going to do, we are going to calculate all the values z function in the vertices. So let's take the first point, that one. So that vertex, it has the coordinates 0 and 2. The next one, we just go on clockwise. So we calculate 6 over 7 and y is 12 over 7. So the next one is 2 and 0, and the last one is 0, 0. So let's start from the bottom parts. Z function, if you plug that into z, 0, 0, we'll get 0 as well. So if you plug 2 and 0, you'll get negative 6, because 5y is just simply 0. All right, so that's right now it's the smallest value. Let's plug 0.2. Definitely we'll get 10. It's not what we're looking for because we need to find the minimum value in this case. So the smallest value is going to be the minimum. And if we plug those 6 over 7, 12 over 7, definitely we'll get value greater than negative 6. But if you like, we can try. So let's just plug the values. So I plug decimals on my calculator. So it's going to be 86 times 3. Oh, 86 times 3. So what I'm going to do, I just plug the fraction. 6 over 7 plus 2 times 12 over 7. And the resultant value is going to be z. Okay, let's calculate that now. So 3 times 6 and over 7. On top of that, 24 over 7. Oh, we've got positive 6. So that's definitely not a minimum value, okay? So that's why the minimum value is right there, and I just highlight as the solution. So negative 2 and 0 will deliver us z to be minimum. So that's the minimum value for z. So that's why the equation of the line for minimum value for objective function is going to be negative 3x plus 5y equals to negative 6. And that's the minimum z. So hopefully you did the same. If not, one more time, try to check up your working. So probably something wrong, I don't know. So it's your responsibility to check yourself. But here is my solution, here is my way. Just share the comments on what's wrong with your guys. Probably you succeed and get the same answer. So if you have a look at your solutions in your book, so solutions in your book actually is going to be, let me see, you can find by the way in the description. So the link where you can download all the solutions. So that's question 2. And yes, actually they have the same points right there. However, the coordinates are different. So they have 4 and 0, and the minimum value for z is going to be negative 12. All right. So that's the way how you can find resemblance, okay, between my examples and what you have in your books, guys. So hopefully you understand that, and I hope that you progress through the topics. So probably I can pick up maybe a bit more examples from there, and then I switch to problem solving, actually types of the problem, like dedicate time to resolve the problem, and we'll be focused more on this, okay? So I mean exercise 12.2. All right, so that's done. That was Daniel Dallas. Hope you like that. Hope you understood. That's the key goal of my explanation, and see you later.